But first, let me give you the final graph and big picture of this. Sea level over 400,000 years has moved up and down in a pattern, sort of a pattern. When you lay on top of that global average temperature in red and greenhouse gases, carbon dioxide in green, an amazing picture becomes clear. And any of you that get into teaching this, I'd be glad to share this slide with you. It's a slide I assembled with the help of Dr. James Hansen, who's probably the foremost climate scientist on the planet. He recently retired as head of NASA's Earth Science program. And Dr. Hansen has been one of the real clarion voices about climate change since the early 1980s. And he'd done parts of this graph, but never assembled it quite this way, and now he uses it too. It's in my book in black and white, but it's easier to kind of discern here in color. So sea level moves up and down in a pattern, temperature moves up and down in a pattern as global average, and then greenhouse gases do. And what's very obvious to see is that there are 4 cycles in this graph, not exactly the same, but pretty close. And the peaks all line up. Well, why would that be? Well, greenhouse gases trap heat, and that's why the planet warms. And I know there's a few questions, I'll answer them in just a minute. So that affects temperature, and as temperature warms, the ice sheets melt and sea level rises. So that's why those 3 lines move together in general. There's lag times. This is 400,000 years. It doesn't happen in a year or a decade. It takes a long time to melt ice. It takes even longer to grow the ice sheets. If we were able to figure out how to stop warming the planet and got it back to its cooling phase, which is where it should be right now, it would still take a long, long, long time to get the ice sheets growing again and reducing sea level. You can understand that. It's a very, very slow process. We think a year is a long time. We think a century is forever. In geologic time, that's not even a blink of an eye. 5,000 years is considered a quick event. Now, the information that comes, I think this slide teaches more about climate than any other single image there is. And not just because as I say, I'm responsible for creating it, but I want to give Dr. Hansen credit for it. But it shows the big picture, and it shows a couple of interesting things. There's a boundary, and we could go back 4 million years instead of 400,000 years. It would be the same picture. That sea level raises up and down about 350 feet, 300 or 400 feet. Temperature, global average changes 9 degrees Fahrenheit, 5 degrees Celsius. And carbon dioxide ranges from 180 to 280 parts per million. I round numbers off to make them easy to remember. That's all you need to remember about those numbers. And the problem is in the upper right, that little vertical green line that's circled in red. That's carbon dioxide. It's broken out of the natural range of 180 to 280, and it's now at 400 parts per million and climbing straight up because of greenhouse gases. Okay? Like a rocket. 40% higher than any time in the last 10 million years. The other thing I want you to take away from this slide before we move on, if you look at the end, is of course that we are at the warm spot in the cycle. And you can see that if you look at this 100,000 year cycle of climate change, of ice ages, that we probably were at the point where we would have started entering the cooling phase, when sea level would have begun an 80,000 year fall toward the next ice age as the planet entered a cooling phase. We've changed things. We haven't just accelerated climate change. There is a natural climate cycle. We would call it the ice ages as one example, as a cycle, a natural cycle, that was driven by a solar variation. It happens about every 100,000 years, and it's because of the shape of the orbit around the sun and the tilt and the wobble of the Earth. Those kind of 3 things all affect how much energy we get by a little bit, just like summer and winter vary the amount of energy we get, and we get summer and winter, cooler and warmer seasons, right? Well, because of those 3 other factors, orbital factors, we're getting a super summer winter every 100,000 years. That's the ice ages. Natural cycle, written in the rock record, proven by sea level and the shoreline, right? But here's the problem. We've broken out of that. This liberating all the fossil fuels and the carbon dioxide, the carbon, is a very powerful insulator. It'd be like with your house putting 10 times more insulation in the attic and not turning down the furnace. The house is going to get hotter, right? That's what we're doing. How do we know that? People say, how could you possibly know that data going back 400,000 years? Well, we have a great technology. In fact, I like to say it's a cool technology because it's the ice cores. We drilled down in the ice sheet. Sorry, that was a bad pun. But this cool technology is that we drill down and get these core samples out of Greenland and Antarctica. And it's very much like taking a sample from a tree and counting tree rings and looking at what happened 40 years ago and seeing that there was a fire or there's a drought and things like that we can do from tree rings. We can do the same thing going down in the ice core, because if you look in the lower left there, that person's holding up a core sample that probably spans, I don't know, about 15 years, but in the fingers of somebody in the lower right is a year of ice. That the snow gets compacted to ice and the ice gets pressurized into pressurized ice under thousands of feet of ice, miles of ice. And the bright spots there are air samples. It's a great technology. It's only been around about 20 years. And just like, it's like molecular medicine type things, when they go in and we can learn things we weren't able to see before at the molecular level, or cellular level, I should say. But we can get the percentage of carbon dioxide that existed up to 800,000 years ago. And we know temperature, not because of the temperature of the ice, of course, that's 32 degrees, but there's two different isotopes of oxygen, 16 and 18. And they vary in proportion to temperature because they have different molecular weights. Really simple physics. And they are good indicators, because this has been done now from Antarctica to Greenland, and it's been done by about 10 different countries and 10 different universities, and they all pretty much come up with the same picture. So we know this is good science. They're not colluding. They're not making up a story. And it's a great record. And it shows us how much carbon dioxide and how temperatures change. And then we get sea level from looking at ancient shorelines that are now underwater or up above sea level these days. So all of this comes together as this picture of carbon dioxide, global temperature, and sea level or the shoreline. It's not assembled from models. It's assembled from history, from geology, from things we can measure. People like to distort and they like to paint their own picture. You may have seen a graph a little bit like this, or this one, or parts of it. Some people have tried to say that follow some of the blue lines. This is showing since 1970 to the present global average temperature. And some people like to carve off parts of this and show that parts of temperature aren't rising. I don't know if you can see it in the back of the room, but there's a red diagonal line that spans 40 years, and there's six different blue lines, can you see them, that follow shorter time periods. And what a lot of people who want to confuse you, I would call them deniers, or people who just have their head in the sand, say is, well, let's look at 7 years or 17 years. And if you look at that choice of years, we can draw a line showing the temperature isn't rising. Well, if you believe that, I have some investments I want to sell you. If I get to choose the time frame and say, don't ignore the big picture. Look at 7 or look at 17 weeks, right? This company did great. You wouldn't do that. We need an objective, unbiased sample. Decades, multiple decades, etc. Because what you see here is there's a pattern. That global average temperature has been steadily rising. It looks like a staircase. There is actually some good reasons for this that I can't get into here. I explain some of them in my book. But this all makes sense if you want to step back and look at a big picture. So we know enough now that with greenhouse gases where they are and because of our energy sources that we can't stop immediately. And even if we did stop putting fossil or carbon dioxide in the air immediately, if we went 100% solar now, sea level's still going to rise because the heat's already been locked in the ocean. The ice sheets are going to melt for centuries. We can slow it, and we should try and do that. We really should. We should do everything possible to slow the rise of temperature. But we've got 7 billion people on this planet, headed to 10 billion. And each of those people, on average, wants to use more energy. And this afternoon, you're going to hear from Seth, I think is in the audience, who's going to talk to you about energy source and options. And there's a big, honest debate about whether we should use nuclear. And you heard Helen Caldicott, who's an esteemed expert, who doesn't believe we should use nuclear because of the health risks and so on. And that's a fair discussion to have. But I know this, the more carbon dioxide we put up in the air, the more this planet's going to warm. And 7 billion people headed to 10 billion is just a reality, even with better family planning and all the other things that go with it. We should do those things, but we need to be realistic here. There's a range to the greenhouse gas, to the temperature, and to sea level over the coming century. And if we do the right things, we can keep it on the low end of the range. But it is not stoppable, like stop it in its tracks. So for those that want, to dig deeper on this, again, I'll be out there selling books later, thanks to Steve and Brian and the bookstore here. But it's also available as an ebook online through Kindle, and my website's for free, the blog posts, and I give a lot of this information for free there. There's no ads or capturing names. I really am trying to help people see things differently, because I believe that we can see this as a glass half empty or half full. People say, John, what could possibly be the good news about sea level rise? Well, I say, first of all, it's a reality check. It is what it is. I mean, it's not what I want it to be. And the truth is, sea level changed hundreds of feet in nature. We just were ignorant. We were fooled because we came along at the end of a 20,000-year rise in sea level before it was about to turn the corner for an 80,000-year fall of 300 or 400 feet. We arrived at slack tide. When you drive up to the inlet of a marina and the water has been coming in as the tide rises and churns around for 20 minutes before it starts to go out, that's called slack tide. If you just pulled your car up to the inlet or the fishing dock at a coastal marina, at slack tide, it would look like sea level didn't change, right? If you stayed there for the 6.5-hour cycle, you would see it go up and down 3 feet, or whatever it does in that location. Some places 25 feet. So it's perspective, and it's awareness, and it's understanding, and that's reality. And that's part of our learning about health for ourselves, the planet, our communities, and financial health, because the fact is the shorelines just started to move. They put in $15 million of pumps in Miami as the first phase of a $300 million program, so that every 28 days they didn't get salt water on the streets, Alton Road and some place like that, if you know South Miami Beach. But it's not just Miami, it's neighborhoods from Vancouver to Monaco to certainly Bangladesh and Vietnam and Bahamas. It's all over the world, every coastal community in the world. So what could possibly be the glass half full? Well, I'm going to admit up front, it took me a while to think of this, because as I was writing the book and looking at my daughter as she was growing up, I said, this cannot be just a depressing story. But first let's start with reality, the truth. Let's learn, as Brian says, let's learn every day and get insight from facts about our bodies, about what we do to them, but about the planet too. And here are my 3 takeaways that I suggest to you can be the glass half full here, the positive viewpoint. That most disasters come at us without warning. The hurricanes, certainly the tsunamis, the tornadoes, things like that, earthquakes, avalanches, we just saw in Nepal. It's hard to plan for that, frankly. Here we have decades or centuries of warning that sea level is going to rise and move the shoreline inland. If we can't begin adapting to that, we are idiots. We deserve to go underwater. I mean, if you can't understand that ice melts at 32 degrees and that there's enough out there, to raise sea level that much, we're stupid. But no, we're better. We can learn. Second thing is, once we apply ourselves to things, we do amazing things. We know that, from cell phones to putting man on the moon to different molecular technology and medicine and things like that. We do great stuff. Once we focus on a problem and stop playing games and denial and, well, it's going to be really expensive to get off of coal and, all these other denialist delay tactics, just like we heard when we were kids, most of us, about smoking and cancer, as Margaret or Helen talked about last night, that there's a vested interest by businesses to preserve the status quo. I understand that, and I don't think they're the bad guys. I think we need some simple rule changes. We need to price carbon. There needs to be an escalating cost to turning carbon into energy, because carbon is the cause of the problem. There should be some kind of carbon tax, fee and rebate. There's lots of potential schemes. But there's a cost to it, just like there's a cost to cigarettes and public health and dealing with people with lung cancer. And just like we've figured that out and put warnings on and taxes and things like that to try and disincentivize people to smoke. And I think we need to do the same thing with there's in coal and solar and renewable energies and nuclear and so on, because it's carbon that's causing the problem. But we can't fix it quickly. So we're going to come up with technologies architecturally, engineering-wise, planning-wise, but it's in fact finance and law and accounting. We're going to have to start amortizing coastal assets. Right now, if you have a $10 million piece of land on the coast, you don't amortize it. It's kept on your personal or corporate balance sheet forever because it's assumed to be permanent. Buildings and infrastructure amortize typically over 30 years. In other words, you follow what I'm saying, if you put a $30 million building, a resort or an office building on the coast, the land on your balance sheet stays there. But the $30 million, you write off $1 million a year typically, knowing that it has a finite life. Well, the land has a finite life too now on the coast. It's like leasehold. We need to realize that. It may take 100 years, it may take 200 years, but at some point we need to write those assets off. That's going to change our accounting system. I mean, so this is the most profound change that can happen to the planet in terms of the 72% that we thought was ocean and the 38% that we thought was dry land. That's going to change. There is no doubt. Does anybody dispute that that's going to happen now with what they know? No. It's not possible to dispute it. Some places like the southeastern United States, where we are today, are more vulnerable than others. But some places are even worse than us. Bangladesh, Vietnam, tens of millions of people in those countries. Countries that will disappear. You've heard the Maldives, Kiribati, Tuvalu, be the first to go underwater. Parts of the Bahamas, where I used to live. Miami, within 100 years or so, roughly, who knows, maybe 60, maybe 160, but will be a tiny community of islands that they've built up a few of them higher and higher, and just with canals, but it won't be the city that we know today. We're going to adapt. You don't have a choice about adapting to sea level rise. It's not, I mean, really think about it. I mean, if the water's around your ankles, what are your choices? You get on you move to higher ground, or you move, or you get wet. This isn't an option. And so the first thing is we've got time to plan. The second thing is we will do some really neat things technologically once we focus on this problem and say we want to deal with this, both slowing it and adapting to it. And the third is you all have an opportunity to communicate. Whether you use my book or borrow some of my slides or just get educated about this, that's fine. This is the biggest game. It's just like the issues about health in your bodies that you're here in the rest of these seminars with the real truth about health. This is a matter of sharing with your family and friends and loved ones and community, fellow investors, and of course your members of Congress, because for some reason they have become beholden to people with very immediate commercial interests. And I don't hold the business community guilty. Some of them are pretty enlightened, actually. But their goal is to make as much money for you as investors as they can, and that's understandable. But we now realize that there is a systemic, permanent risk to humanity if we let carbon dioxide keep escalating. This idea that we can adapt to climate change is disproven by sea level rise. In other words, there is no easy way to adapt to flooding cities. And even if we slow global warming, it's going to happen. So that becomes a very powerful tool to persuade and convince and reset our priorities. We need to create incentives for people to migrate to renewable energy. But we've got to recognize that at this point, we are going to get to at least 9 billion people, even if we did better family planning. Maybe we can keep it from being 12 or 10. And those people want more energy. So that's a sobering reality. But this is either the worst news, or as I said last night, it's actually, to me, again, the glass half full could be the best news. This could be the one problem that causes us to think different, that you just can't avoid, that's inarguable. It's not, well, how come it's raining more here and droughts in California? And how come it's more snow here? Those are fair questions, and there's a good answer to every one of those questions. But the fact is, you can't argue with that as the ice sheets get smaller and sea level rise and the shoreline moves inland, that it's going to affect real estate, the most tangible of all investments. It's where we live. So let's use this reality to teach. This is a revolutionary reality. Does anybody dispute that? It's a phrase I came up with. I like it, okay? Revolutionary reality, a little alliteration. This is about as revolutionary as anything gets. And it's a teaching opportunity. And for those who've been more ecological and holistic and environmental and sustainable and all those things, which are great, I hope you add this tool to your toolkit, but it also lets you think bigger. And hopefully connects a lot of the dots. Because as part of this teaching, what I like people to come away with is to realize there is a bigger picture, and that it's not just a matter of going solar or driving a Prius or changing light bulbs or resetting the thermostat or using recycled paper or all those other very good things which I do. Those things are not going to stop climate change. Now, we all need to do them, but we also need to adapt. So that's why I come down to, when people say, what should we do? I say, well, we need to adapt to climate change, and the most powerful manifestation or effect of that is sea level rise moving the shoreline. We need to adapt to it. And at the same time, we need to take that awareness of our vulnerability and what's at risk and work harder than ever to slow the warming. We've got to do two things. It's not one or the other. We have to do both. I really hope you join me, get the word out. I'm just one voice. I've given some of you some tools already. I hope you go on from there. We need to expand the network.